Prepare yourself. The James Webb Space Telescope has just delivered revelations so mind-bending they could rewrite the very fabric of reality. What if alien life isn't just a possibility but a truth hidden in plain sight? What if the origins of our universe hold secrets far more profound, or unsettling, than we ever imagined? These discoveries have shattered what we thought we knew, leaving us with even bigger questions. Are we truly alone? And what else lies waiting in the vast, uncharted cosmos? Buckle up, because this changes everything. Let's explore and find them together right now. Part 1. The Majestic first images from James Webb. When the first images from the James Webb Space Telescope were revealed, they weren't just photographs, they were portals to a time when the universe was in its infancy. Among the most breathtaking sights was the light emitted from galaxies a staggering 13 billion years ago. Captured in exquisite detail, these galaxies, some swirling in delicate spirals, others colliding in cosmic chaos, tell a story of creation and transformation. Each starburst and shimmering cloud of gas in these images offers a glimpse into the distant past, a time when the first stars began to ignite the darkness. Imagine seeing a tapestry of galaxies in rich colors, fiery reds, brilliant blues, and subtle golds that seem to shimmer against the inky backdrop of space. James Webb's infrared vision allows it to cut through the dust and gas that previously obscured these ancient wonders, revealing structures and details that no telescope before it could hope to capture. Unlike the Hubble Space Telescope, which gave us breathtaking images in visible and ultraviolet light, Webb delves deeper, allowing us to witness what Hubble could not, a universe in its earliest stages of development. If Hubble was like viewing the cosmos in crisp black and white, James Webb feels like stepping into a vibrant 4K cinematic masterpiece. One of the most awe-inspiring images was that of the Carina Nebula. This massive star-forming region, previously shrouded in mystery, now stands illuminated in stunning clarity. The pillars of dust and gas, often referred to as mountains of creation, glow with radiant light, unveiling pockets where stars are being born. These structures, shaped by the winds and radiation of massive stars, are both beautiful and destructive, a perfect balance of chaos and order. Seeing them so vividly, one can almost feel the heat of the young stars or the icy chill of the void around them. Equally mesmerizing were the images of Stephan's quintet, a cluster of 5 galaxies locked in an intricate cosmic dance. Some of these galaxies are merging, their gravitational pull distorting their shapes, creating tidal tales of stars and gas that stretch across millions of light years. In one corner, a supermassive black hole at the heart of one galaxy actively feeds on surrounding material, emitting jets of energy visible for the first time in infrared light. These images not only provide a feast for the eyes but also a treasure trove of data for scientists studying the dynamics of galactic evolution. Another monumental achievement was Webb's ability to capture the most ancient light ever observed, the so-called cosmic dawn. This faint glow, emitted by the first stars and galaxies as they emerged from the cosmic dark ages, is a direct window into the birth of the universe. Webb's instruments can detect this light with unparalleled sensitivity, allowing scientists to measure the age, composition, and behavior of these primordial objects. It's as if we're holding a magnifying glass to the early universe, unraveling secrets that have been locked away for billions of years. But it's not just the science that captivates, it's the emotion these images evoke. To look at them is to stare directly into the past, to witness moments that occurred long before Earth, our sun, or even our galaxy existed. It's a humbling reminder of our place in the cosmos. These images are not mere snapshots, they are time capsules, carrying the echoes of creation across the expanse of space and time. For scientists, the first wave of images from Webb marked the beginning of a new era in astronomy. For the public, they sparked awe, curiosity, and inspiration. What else might Webb reveal as it peers deeper into the cosmos? What other secrets lie hidden among the stars? These first images are only the beginning, a preview of the unimaginable discoveries yet to come. They are a testament to human ingenuity, a symbol of what we can achieve when we dare to ask the biggest questions. Through James Webb's lens, we are not just observers of the universe, we are participants in its story. Every swirling galaxy, every shimmering nebula, And every faint glimmer of light tells a story billions of years in the making. These images remind us of the beauty and complexity of the cosmos and our unyielding desire to understand it. In every pixel of these extraordinary pictures lies the promise of discovery. The universe, vast and ancient, has begun to unveil its secrets. And thanks to James Webb, we're finally starting to see it in ways we never thought possible. Part 2. Discovering signs of life on alien worlds. The James Webb Space Telescope has taken humanity closer than ever to answering one of the most profound questions. Are we alone in the universe? With its unprecedented sensitivity, Webb has unveiled tantalizing clues in the atmosphere of an exoplanet, an alien world orbiting a distant star. Among these findings are traces of methane, carbon dioxide, and even water vapor, compounds that could signal the presence of life or, at the very least, the conditions necessary for it to exist. One of the most remarkable exoplanets under Webb's scrutiny is an intriguing world unofficially dubbed Earth 2.0. This planet resides in the Goldilocks zone, a region around its star where conditions are just right for liquid water to exist, a critical ingredient for life as we know it. Unlike the scorching infernos of Venus or the frozen deserts of Mars, Earth 2.0 appears to sit comfortably in the middle, with temperatures that might allow rivers, lakes, or even oceans to form. Could this alien planet be harboring microbial life, or perhaps something more advanced? The mere possibility has ignited imaginations worldwide. Webb's advanced instruments have detected a chemical cocktail in this planet's atmosphere, one that is both fascinating and mysterious. Methane, for example, is often produced by biological processes here on Earth, such as by microorganisms breaking down organic material. While methane can also be generated through geological activity, its presence, alongside water vapor and carbon dioxide, paints a compelling picture of a potentially habitable world. The data suggests a dynamic atmosphere, one that may even experience weather patterns similar to our own, complete with clouds and precipitation cycles. But the story doesn't end there. Scientists have begun exploring the possibility of detecting vegetation on distant planets, a revolutionary concept known as the vegetation red edge. This phenomenon occurs when plants reflect infrared light, creating a distinct spectral signature. On Earth, this red edge is a hallmark of photosynthesis, the process through which plants convert sunlight into energy. If a similar signature were found on an exoplanet, it would provide strong evidence for the presence of plant-like life forms. Imagine the implications. Fields of alien flora thriving under an unfamiliar sun, contributing to a biosphere entirely separate from ours. The comparison between Earth 2.0 and our own planet deepens the intrigue. On Earth, the combination of methane, carbon dioxide, and water vapor in the atmosphere is a byproduct of life. From microbial activity to volcanic eruptions to human industry, the parallels are hard to ignore. Could the same chemical interplay be unfolding on this distant world? If so, it raises even more questions. What type of organisms might exist there? Could they be carbon-based, like life on Earth, or might they follow entirely different biological rules? James Webb's findings also highlight the unique challenges of studying distant atmospheres. While Webb's instruments can analyze light passing through an exoplanet's atmosphere as it traverses its star, this technique requires incredible precision. Each molecule absorbs light at specific wavelengths, leaving behind a fingerprint that scientists can decode. It's through this method that the presence of water vapor and methane was confirmed, giving us a glimpse of the planet's composition and, potentially, its habitability. Earth 2.0, however, isn't without its challenges. Despite its promising location in the Goldilocks zone, its parent star, a red dwarf, is known for emitting intense solar flares. These flares could strip away the planet's atmosphere over time, rendering it uninhabitable. Additionally, if the planet is tidally locked, one side would perpetually face the star, creating scorching heat, while the other side remains in freezing darkness. Yet, even these extremes don't entirely rule out the possibility of life. Some researchers speculate that a twilight zone between the two hemispheres could harbor stable conditions, potentially supporting life forms adapted to such extremes. The discovery of these atmospheric signatures is more than just a milestone in astronomy. It's a glimpse into a future where identifying habitable planets, and perhaps visiting them, becomes a reality. With advancements in space exploration and technology, we are inching closer to answering the age-old question of whether Earth is unique or just one of many cradles of life scattered across the cosmos. For now, Earth 2.0 serves as a powerful reminder of the vast potential that lies beyond our solar system. It represents the possibility that we may not be alone and that the universe might be teeming with life in forms and environments we've yet to imagine. James Webb has opened a door to a universe filled with promise, and what lies on the other side could redefine not only our understanding of life but also our place in the cosmos. Part 3. Unveiling the building blocks of life in molecular clouds. The James Webb Space Telescope has ventured deep into a molecular cloud, one of the coldest and most mysterious regions of the universe, and uncovered a treasure trove of prebiotic molecules. These simple yet essential compounds, methanol, ammonia, and water ice, are the building blocks of life, laying the foundation for organic chemistry and, potentially, the emergence of living organisms. Molecular clouds are immense interstellar nurseries where stars and planets are born. In the frozen depths of these clouds, temperatures plummet to nearly -450 degrees Fahrenheit, -270 degrees Celsius, creating an environment where molecules adhere to dust grains, forming icy mantles. These mantles act as natural laboratories, facilitating chemical reactions that led to increasingly complex compounds. Among these are methanol and ammonia, two key ingredients for forming amino acids, the fundamental components of proteins. The discovery of these frozen molecules is significant not only because of their presence but also because of the insights they provide into how life might originate elsewhere in the universe. Using advanced infrared spectroscopy, Webb's instruments identified the unique spectral signatures of these compounds, offering an unprecedented glimpse into the chemistry occurring within molecular clouds. This process mirrors the conditions thought to exist on early Earth, where similar reactions may have given rise to life billions of years ago. One of the most exciting implications of this finding is the potential for these molecules to evolve into even more complex organic compounds, such as amino acids and sugars. Scientists hypothesize that cosmic rays or ultraviolet light passing through the cloud could provide the energy needed to drive these reactions. This means molecular clouds may not just be passive regions of space but active crucibles for life's precursors. These clouds are vast, spanning dozens of light years and containing enough material to form thousands of stars. As stars form, their energy begins to heat the icy mantles, releasing the trapped molecules into the surrounding space. This creates chemically enriched regions that serve as the starting points for the formation of planets, and potentially, the beginnings of biological activity. To envision the significance, think of these molecular clouds as the universe's version of a primordial soup, a vast, cold, and fertile environment where life's seeds are sown. If the ingredients for life are this abundant, it suggests that the emergence of life might not be an extraordinary event but a natural process repeated across countless star systems. Through the lens of James Webb, we are not just observing distant chemistry, we are witnessing the first steps in a universal journey that may lead to life. These findings provide a tantalizing hint that the cosmos itself might be predisposed to fostering life, making the search for its origins more compelling than ever. Part 4. Exploring Proxima b, a prime candidate for life. Among the countless exoplanets identified so far, Proxima b stands out as one of the most compelling candidates for harboring life. Orbiting the red dwarf star Proxima Centauri, just 4.2 light-years away from Earth, this rocky planet resides within the Goldilocks zone, a region where conditions could allow liquid water to exist on its surface. Its proximity to our solar system makes it a tantalizing target for exploration, sparking scientific curiosity and opening the door to groundbreaking possibilities. Proxima b's location in the habitable zone suggests it might have temperatures that allow water to remain in liquid form, a crucial requirement for life as we know it. The planet is roughly the size of Earth, with a similar mass, further increasing the likelihood of it being rocky and capable of supporting an atmosphere. Early observations hint at the potential presence of gases such as carbon dioxide, which could help regulate surface temperatures and support a stable climate. Despite its promise, Proxima b faces significant challenges. Its host star, Proxima Centauri, is a red dwarf known for emitting intense solar flares. These powerful bursts of radiation can strip away a planet's atmosphere over time, leaving its surface exposed to the harshness of space. Additionally, Proxima b is likely tidally locked, meaning one side of the planet always faces the star, resulting in extreme temperature contrasts. The day side could be scorching hot, while the night side remains perpetually frozen. However, scientists speculate that a twilight zone between these extremes might offer a stable environment where liquid water, and potentially life, could exist. The potential for habitability on Proxima b has inspired discussions about future methods of study. One promising avenue involves the use of advanced telescopes like the James Webb Space Telescope to observe the planet's atmosphere in greater detail. Webb's powerful instruments can analyze starlight passing through Proxima b's atmosphere during its orbit, identifying the chemical fingerprints of gases that might indicate biological activity. For example, the detection of oxygen, methane, or water vapor in specific combinations could point to active life processes. Looking further ahead, more ambitious proposals include sending probes to Proxima b Breakthrough Starshot, a project aiming to develop ultra-fast light-sail spacecraft. Could enable us to reach the planet within a few decades. These tiny, high-speed probes would carry cameras and sensors to capture close-up images of Proxima b's surface, providing unprecedented insights into its geology and potential habitability. The idea of sending a message to Proxima Centauri has also been floated, raising fascinating questions about how we might communicate with any intelligent life forms that could exist there. Proxima b's comparison to other planets in the Goldilocks zone further underscores its uniqueness. While many exoplanets have been discovered in habitable zones, few are as close or as well suited for detailed study as Proxima b. Its proximity allows us to study its environment with greater precision than more distant worlds like Kepler 452b or TRAPPIST-1e. Additionally, its location around a red dwarf star presents a different set of challenges and opportunities compared to planets orbiting stars like our Sun. Understanding Proxima b could provide crucial insights into how life might adapt to environments vastly different from Earth. The possibility of liquid water on Proxima b makes it particularly intriguing. Water is not just a solvent for biochemical reactions, it also provides stability and protection against radiation. If Proxima b has underground reservoirs or surface lakes in its twilight zone, these could serve as havens for microbial life. Additionally, the presence of a magnetic field, if confirmed, would offer further protection from Proxima Centauri's solar flares, enhancing its chances of habitability. For humanity, Proxima b represents more than just a scientific curiosity. It's a symbol of what might be achievable as we expand our reach into the cosmos. It embodies the hope that we might not be alone, that somewhere out there, another world teems with life. Whether it's a bustling ecosystem or simple microbial life, the discovery of life on Proxima b would forever alter our understanding of our place in the universe. While challenges remain, the tools and technologies at our disposal are rapidly advancing, bringing us closer to answering the age-old question of whether we are alone. Proxima b serves as a reminder of both the incredible diversity of planets in our galaxy and the vast potential for discovery that lies ahead. Through telescopes like James Webb and the daring ideas of interstellar exploration, we are taking the first steps toward unraveling the mysteries of this enigmatic world, and perhaps finding the answer to one of humanity's greatest questions. Part 5. The smallest asteroid in a dusty disk around a red dwarf. In its relentless quest to uncover the secrets of the universe, the James Webb Space Telescope has made yet another remarkable discovery: the smallest asteroid ever observed. Measuring between 100 and 200 meters in length, roughly the size of Rome's Colosseum. While diminutive compared to other celestial objects, this tiny asteroid provides scientists with invaluable insights into the early days of our solar system and the processes that shape planetary formation. Asteroids like this one are often referred to as time capsules, because they preserve the conditions of the early solar system. These remnants of ancient collisions and aggregations of dust and rock are key to understanding how planets, including Earth, came to be. By studying this asteroid's composition, structure, and orbit, researchers can piece together the puzzle of planetary formation. Webb's ability to detect such a small and faint object highlights its extraordinary sensitivity and opens the door to studying many more objects of this scale. But the discoveries don't stop there. Webb has also turned its gaze toward a dusty disk surrounding a nearby red dwarf star, uncovering new clues about the formation of planets. These disks, composed of gas, dust, and rocky debris, are the birthplaces of planets. As particles within the disk collide and stick together, they gradually grow into larger bodies, eventually forming planets and moons. Webb's advanced infrared capabilities allow it to penetrate the thick layers of dust that obscure these disks, revealing their structure and composition with unprecedented clarity. The dusty disk observed around this red dwarf star is particularly fascinating because it may resemble the early conditions of our own solar system. By analyzing the disk's properties, scientists can better understand how terrestrial planets like Earth emerge from these primordial clouds. Webb's data shows that this disk contains not only the raw materials for planet formation, such as silicates and carbon compounds, but also evidence of turbulence and clumping, processes critical for the growth of planets. What makes this discovery even more compelling is the potential to combine Webb's observations with advanced computer simulations. These models allow scientists to recreate the conditions within the disk, simulating how particles interact, coalesce, and eventually form planets. By comparing these simulations to real-world data from Webb, researchers can refine their understanding of the mechanisms behind planet formation. This iterative process of observation and modeling brings us closer to answering one of astronomy's most fundamental questions: how do planets like Earth come into existence? The dusty disk around this red dwarf star also offers an opportunity to study the role of star type in planet formation. Red dwarfs are the most common type of star in the galaxy, and many exoplanets have been found orbiting them. However, the intense radiation and stellar flares emitted by red dwarfs pose challenges for the formation and survival of habitable planets. Observing this disk helps scientists determine whether planets in such environments can develop the stability needed to support life. This combination of a tiny asteroid and a dusty disk provides a dual perspective on planetary origins. The asteroid represents the remnants of planetary formation, a piece of the process frozen in time, while the disk is an active site where new planets may currently be taking shape. Together, they offer a complete picture of the life cycle of planetary systems, from their chaotic beginnings to their eventual maturation. The discovery of the smallest asteroid and the detailed observations of a dusty disk highlight James Webb's versatility as a scientific instrument. Whether it's examining the tiniest fragments of the past or the grand structures that shape the future, Webb continues to push the boundaries of what we can observe and understand. These findings don't just expand our knowledge, they inspire us to keep exploring, reminding us that even the smallest objects in the cosmos can hold the biggest secrets. Part 6. Probing the mysteries of dark matter and dark energy. The James Webb Space Telescope is not only shedding light on the visible universe but also delving into its most enigmatic components, dark matter and dark energy. Together, these elusive phenomena account for a staggering 95% of the universe. Yet they remain unseen and poorly understood. Webb's cutting-edge capabilities are enabling scientists to explore these mysteries like never before, offering glimpses into the hidden forces that shape the cosmos. Dark matter, often referred to as the universe's invisible glue, is thought to hold galaxies together, preventing them from flying apart despite their rapid rotations. Without it, the delicate balance of the universe's structure would collapse. Though dark matter itself cannot be directly observed, its presence is inferred from its gravitational effects on visible matter. Webb's ability to study the behavior of light bending around massive objects, a phenomenon known as gravitational lensing, is providing valuable clues about where dark matter resides and how it influences the formation of galaxies. One of Webb's most exciting contributions to dark matter research is its ability to map its distribution across vast cosmic scales. By analyzing clusters of galaxies and their interactions, scientists can pinpoint regions where dark matter is densest. These maps not only reveal how dark matter is spread throughout the universe but also offer insights into its possible composition. Some theories suggest it could consist of exotic particles yet to be detected by current technology. And Webb's observations might bring us closer to identifying these elusive components. If dark matter acts as the framework of the universe, dark energy is its driving force, propelling the cosmos to expand at an accelerating rate. Discovered in the late 20th century, dark energy remains one of the greatest mysteries in physics. Webb's unparalleled ability to observe distant supernovae and ancient light from the early universe is allowing researchers to measure this acceleration with unprecedented precision. These measurements are crucial for understanding the nature of dark energy and its role in shaping the universe's fate. One fascinating hypothesis emerging from Webb's data is the idea that dark matter might act as a cosmic engine, maintaining the structural integrity of the universe. If the universe were a vast, intricate painting, dark matter would be the unseen frame, providing stability and cohesion while remaining invisible to the naked eye. This poetic analogy underscores the profound role dark matter plays in the cosmos, even if its exact nature remains elusive. Webb's observations also offer a chance to test competing theories about the universe's underlying structure. For example, some researchers propose modifications to Einstein's theory of general relativity to account for the effects of dark energy and dark matter. Others suggest that these phenomena might be evidence of entirely new physics waiting to be discovered. Webb's detailed studies of cosmic expansion, galaxy clusters, and the large-scale structure of the universe could provide the data needed to settle these debates. The telescope's ability to peer back in time by capturing light from billions of years ago is particularly valuable in this context. By studying the early universe, Webb helps scientists understand how dark matter and dark energy influenced its evolution. These observations not only clarify the past but also offer hints about the future, whether the universe will continue expanding indefinitely, slow down, or eventually collapse back on itself in a big crunch. The implications of these discoveries extend far beyond academic curiosity. Understanding dark matter and dark energy could revolutionize our comprehension of fundamental physics, opening new avenues for technological innovation and even altering our philosophical perspective on the universe and our place within it. The search for answers is more than a scientific endeavor. It's a testament to humanity's insatiable curiosity and desire to uncover the unseen. Through the James Webb Space Telescope, we are unraveling the invisible threads that weave the universe together. Each observation brings us closer to understanding the forces that govern the cosmos, reminding us that even in the darkness, there is knowledge waiting to be illuminated. The James Webb Space Telescope is more than just a scientific tool. It's a gateway to a new universe, unraveling profound mysteries about life, origins, and the cosmos' destiny. Each discovery brings us closer to understanding the vast expanse we call home, fueling curiosity and wonder. If you love exploring the universe's mysteries, don't forget to like, share, and subscribe to our YouTube channel. Thank you for watching, and stay tuned for more cosmic adventures.